The purpose of a torque tool is to measure or limit the amount of torque applied at a given point. All fasteners have a torque range they can operate in without being damaged. This torque range changes with the fastener material, hardness, size, and pitch, or spacing of the screw and bolt threads. The reason torque is important is that every type and grade of material has a definite limit to which it can safely be stretched or stressed. This is called the elastic limit of the material. Design engineers will calculate the correct amount of torque to apply to the fasteners that will hold the component parts together. The calculated torque requirement will cause a stress or elongation of the bolt at about 40 to 70% of its elastic limit. Think of it this way. If you were to stress a fastener to 100% of its limit, it would break. Or, if you applied no stress to the fastener, it would simply work its way loose with vibration. The 40 to 70% stress factor is the appropriate tightness that will hold together without causing damage to any of the materials. This is why fasteners must be torqued to their specified value. These torque specifications are typically called out on the assembly documentation, drawing, or work instructions. The torque values, unless otherwise indicated, are typically given in inch-pounds, although this is dependent on the design of the part that's being assembled. Here's what that means. If a 1-pound force is applied 5 inches from the center of the bolt, the resulting torque would be referred to as 5 inch-pounds of torque. In addition, torque values will typically have a tolerance of plus or minus 5%. So if the assembly documentation calls for 5 inch-pounds of torque, the acceptable torque range would be 4.75 to 5.25 inch-pounds. All torque tools have a tolerance or acceptable range of variation from the tool set value. Think of this as an accuracy allowance for the tool. This tolerance is always indicated by the tool manufacturer. Now let's take a look at how running torque, also known as prevailing torque, affects the applied torque required by a fastener.